Hey guys, I hope you're all doing good. In the last video, we looked at some basic geometry manipulation using CONVERGE STUDIO. I was primarily going over the basic geometric entities like vertices, edges, and triangles. And we looked at how you can select them and then how you can delete the triangles and then how you can create triangles using the delete operation and the loft operation. So in this video, I wanted to go over the different types of surface errors that can occur, and we are going to look at this by first taking up a realistic geometry. So here you are looking at a solid piston. People would use something like this to do a conjugate heat transfer analysis. It's very important that the surface looks clean and does not have any of the problems. So here I've loaded a STL file. STL is a popular file format that stores the geometry as triangles. So when I loaded the geometry inside CONVERGE STUDIO, I see all these different colors, right? What do those mean? Anytime the geometry has problems, Studio is going to show that to us. So what we need to do is spend some time in learning what these errors mean, and we need to come up with strategies to tackle it. So the first thing I'm going to do is I have my diagnosis doc open here. As I mentioned in the last video, if you do not see it, go to the view menu and then you should see diagnosis doc. Alternatively, you can do Control D, that's the shortcut. So let's run the diagnosis, and you can see that there are several intersection errors, non-manifold problems, and open edges, okay? And the first thing that we need to do is understand what these errors mean and then come up with strategies on how to tackle them. All right. We won't be working on this geometry yet. This would be in a harder geometry to clean up. So first we are going to move forward to a simpler geometry. We are going to understand what those errors mean. By keeping the geometry simple, we can focus on the errors. Currently there are so many errors that it's making it difficult for us to isolate the problems. So what I'm going to do is I'm going to create a new file, and I'm going to create a box. And I'm doing this by going to the geometry doc, clicking on create, shape, box, use the default parameters and click on create. Now what I'm going to do is I'm going to select the top faces. First I change my entity type by pressing 3. So that's going to enable triangle selection. I'm selecting these two triangles. I'm pressing Ctrl H. That's going to hide the top face. I'm not deleting it, I'm just hiding it. So what I'm going to do next is create intersecting triangles, and the way I'm planning to do that is I'm going to create triangle, and I'm going to create triangle from 3 vertices, and the vertices that I'm going to select are this guy, and this guy. Right, so I'm creating that face there, and similarly I'm going to select this corner vertex, this one, and this one. Okay, so let's take a look at the geometry a bit closer. You can see that I have a cube where I have these two triangles that are just passing through each other. So this is my cube. It looks perfectly fine from the outside, but if I just hide a couple of faces, again for hiding I'm using the shortcut Ctrl H. You can always do a right click and then click on hide selection. All right, so there are several issues going on here. So first you can see that you have these yellow lines. So what do those mean? Yellow lines indicate open edges. So a valid surface is a surface where a triangle, where each and every edge in a triangle is shared by 2 triangles. So to demonstrate that, let's create another shape, and we are going to create another cube, but this time I'm just going to offset the cube by 0.05 so that I create it somewhere else. If you take a look at a triangle here, then what you can do is if I rotate around the triangle, you can see that any given edge in this triangle is shared by 2 triangles. This is the right connectivity that we need. If an edge, for example, let's take this particular edge, okay, and I'm just going to use any type, this particular edge, it's being shared by this triangle and this triangle, okay. So now if I delete one of those triangles, I'm left with an open edge, right? Because now these 3 edges are being shared by only one triangle. This edge is shared by this triangle, this edge is shared by this triangle, and finally this edge is shared only by this triangle. Okay, and that is why we are getting this open edge loop. All right, similarly the other extreme is if you have a single edge that is being shared by more than two triangles, then that edge is called as a non-manifold edge. So non-manifold edge has this purple color here. So for example, if I select this edge, right, you can see that this particular edge is being shared by three triangles. And to make this more evident, I'm going to go to triangle selection mode, select the first triangle, the second triangle, and the third triangle, right click, and I'm going to use isolate selection, or alternatively I can use Ctrl L, and this is just going to isolate the triangles that we clicked on. Okay, this is kind of opposite to the height selection option. So here you can see that this particular edge, which is being colored purple, is shared by more than two triangles, and this is called as a non-manifold edge. Now non-manifold edges are not okay, except if you're doing conjugate heat transfer simulations using CONVERGE CFD. Alright, in general we consider this as invalid triangles. So I'm displaying my geometry again, and this time let's actually hide the faces one more time. I'm using the Ctrl H shortcut there, and we have looked at open edges and we have looked at non-manifold edge. The final thing that we want to take a look at is intersections. So intersections are fairly easy. So let me select the two triangles and I'm going to press Ctrl L. That's going to isolate the selection. So here you can see that two triangles are just passing through each other. Now why does this happen? Most of these surface errors come from the CAD part. So when you create a geometry in CAD, so for example I have this drawing here of a piston part which looks perfectly fine, okay, but when I'm exporting this model as a STL file, then I'm relying upon the software's ability to convert the accurate 3D geometry into a triangulated file.